Okay, now let's say I was hungry, and what I wanted to eat was a ham and cheese sandwich. So what would I do if I wanted to go make a ham and cheese sandwich? Well, I need to go to the fridge and I need to get some bread, which I'll write as BR, and you'll see why. I'm going to need to get some slices of ham, which I'll write as HA, and I'd get some slices of cheese, which I'll write as CH. And that would end up giving me a ham and cheese sandwich. And if we were to write a ham and cheese sandwich as a molecule, it looks something like this. 2 slices of bread, 1 slice of ham, and 1 slice of cheese. Now, the important thing to notice here is that there's 2 slices of bread in a ham and cheese sandwich. You can't have just 1 slice of bread because then it wouldn't be a sandwich. So that means that when I go to the fridge to grab everything to make this ham and cheese sandwich, I'm going to need 2 slices of bread. And this same concept applies to balancing chemical equations. So if I scroll down here, I have the equation to make H2O. So in nature, naturally, sorry about that. In nature, we find hydrogen and oxygen as diatomic molecules. You'll never just find a singular hydrogen atom or a singular oxygen atom in nature. They're always bonded to each other. So that's what diatomic means. Diatomic means 2 atoms. However, in H2O in water, we have 2 hydrogen atoms and only 1 oxygen atom. So even though we have the equation for H2O here, it is not balanced, because if we just added these 2 molecules together, you'll get H2O2, which is hydrogen peroxide, a completely different molecule than H2O. So what are we going to do to fix that? Well, what I can do, I can look for the outlier. So there's 2 hydrogen atoms on the left side and 2 hydrogen atoms on the right side. And there's 2 oxygen atoms on the left side, but there's only 1 oxygen atom on the right side. So what can I do to fix that? Well, I can say, hey, I'll just have 2 molecules of H2O, so that I can then have 2 oxygen atoms. So that fixes that, but that also means that we'll have 4 hydrogen atoms here, right? 2 times 2 times 2 equals 4. So what can I do to fix that? Well, I'll just have 2 hydrogen molecules. So now let's check that we got it right. So we have 2 times 2, so 4 hydrogen atoms on the left side. 2 times 2, so 4 hydrogen atoms on the right side. 2 oxygen atoms on the left side. And 2 times 1, 2 oxygen atoms on the right side. So there, we have our balanced equation. And what this means is that to make 2 molecules of H2O, we're going to need 2 hydrogen molecules and 1 oxygen molecule. And we can also talk about this in terms of moles, right? 6.02 times 10 to the 23rd atoms is 1 mole. So you're going to need 2 moles of hydrogen and 1 mole of oxygen to make 2 moles of hydrogen, of H2O, sorry. So that was simple enough, but honestly, these can get quite confusing. So here we have a lot more going on. This is the combustion of hexane, right? This molecule over here is hexane. So hexane, when reacting with oxygen, produces carbon dioxide and water, right? So even though there's a lot more going on here, sorry, I accidentally wrote on this carbon over here. So even though there's a lot going on here, it's the same process. We just need to be careful that we properly balance everything. So I'm just going to start with an atom that only appears once on both sides of the equation, because here oxygen appears once on the left side but twice in 2 separate molecules on the right side. So that can get confusing. So I'll just start with carbon. Right. So on the left side we have 6 atoms of carbon, and we only have 1 atom of carbon on the right side. So I'll just multiply this molecule, CO2, by 6, so that I can have 6 carbon atoms. Hydrogen also appears once on both sides of the equation, so I'll also do that. So there's 14 hydrogen atoms on the left side and 2 hydrogen atoms on the right side. So what's 14 divided by 2? Well, 7. So then I have 14 hydrogen atoms on the right side and 14 hydrogen atoms on the left side. And that just leaves us with oxygen. So we have 2 oxygen atoms on the left side, but we have 6 times 2, 12. I'll go ahead and write that so we can keep track. 12 oxygen atoms in CO2, and 7 times 1 is 7 oxygen atoms in H2O. So 12 plus 7 is 19. So 19. So we're going to need 19 oxygen atoms on the left side. Well, oxygen, like we said before, is a diatomic. So it occurs as 2 oxygen atoms in an oxygen molecule. So what I can do is I can just put 19. Oop, I need to write that in blue, sorry. I can write that as 19 over 2, right? 19 over 2, because if we multiply this by 2, because there's 2 oxygen atoms in an oxygen molecule, we'll get 19 singular atoms of oxygen. Now, this is okay, however, we do not like to have halves or portions or fractions of molecules or atoms in a balanced equation, because molecules do not occur as fractions, they occur as whole molecules. So what can we do to fix this? Because we can't have 19 over 2 oxygen molecules. Well, what we can do is we know from math that if I were to multiply this whole thing, the whole left side of the equation by 2, as long as I multiply the whole right side of the equation by 2 as well, sorry that cut in there, then we should be good. So that means that we will have 2 molecules of hexane plus 2 times 19 over 2 is just 19 molecules of oxygen. 2 times 6 is 12 molecules of carbon dioxide, plus 7 times 2 is 14. Let me get the right color here. 14 molecules of H2O, or water. Let me go ahead and write that, sorry. So here we should have a balanced equation with whole numbers of molecules now. So let's just check. On the left side we have 12. I'll go ahead and write this. On the left side we have 12 atoms of carbon. On the right side we have 12 molecules of carbon. For hydrogen on the left we have 28 atoms of hydrogen. On the right side we have 14 times 2, which is 28 atoms of hydrogen. And on the left side we have 19 times 2, which is 38 atoms of oxygen. Sorry, this looks like an U, that should be an O, oxygen. On the right side we have 12 times 2, which is 24, and 14 times 1, which is 14. 24 plus 14 is 38. 38 atoms of oxygen. So here is our balanced equation. So even though that was a lot longer, as long as you follow the process of going one atom at a time, start with an atom that only appears once and work from there, you should be fine balancing chemical equations.